Okay, in section 2.3, we're talking about linear inequalities. Let's let A, B, and C be real numbers. If A is less than C, then A plus C is less than B plus C. And if A is less than B, A times C is less than B times C, only if C is greater than 0 and A times C is greater than B times C if C is less than 0. Similar statements would apply for greater than, less than or equal to, or greater than or equal to. So for example, if 1 is less than 2, and you multiply both sides by -1, -1 is greater than -2. Okay, that's a true statement. If 1 is less than 2 and you divide both sides by -2, -1/2 is greater than -1. Okay? So in general, you're only going to flip the sign if you multiply or divide by a negative number. Okay. For example, suppose that we want to solve the inequality given by 1 minus 2x greater than 2 minus 3x divided by -4. Well, the first thing I'm going to do is I'm going to multiply both sides by -4. And since I'm multiplying by a negative, I got to flip the sign. When I add 3x and then add 6, 11x is less than 6. So x is less than 6 over 11. Set of all x such that x is less than 6 over 11. It would be my answer using set builder notation and using interval notation, -infinity to 6/11. Make sure that there's a parentheses by 6/11. If we were to graph on the number line, 6/11 is our number, which we're not including. Anything less than that, though. Okay, so suppose that we want to solve -2 less than greater times 5 plus 3x less than 6 less than or equal to 6 minus 2 times the quantity x minus 2. When I distribute -2 into those two terms, -2 times 10 is -10. -2 times 3x is minus 6x, less than or equal to 6 minus 2 plus 4. Okay, 6 plus 4 is 10. If I add 10 to both sides and I add 2x to both sides, -4x less than or equal to 20. And if I divide both sides by -4, because I'm dividing by a negative, I need to flip the sign. So x is greater than or equal to -5. Set of all x such that x is greater than or equal to -5. -5 to infinity, make sure that's a bracket by -5, and you got a closed circle there. Okay. The expression a less than x less than b is called a compound inequality, and it means a is less than x and x is less than b. So for example, suppose that -4 is less than or equal to 9x plus 14, which is less than 21. Okay, I can split this into two inequalities and write the word and between. -4 less than or equal to 9x plus 14 and 9x plus 14 less than 21. Okay, if I subtract 14 from both sides, -4 minus 14 is -18, less than or equal to, greater than or equal to 9x. And if I subtract, it's 14, 9x less than or equal to 7. And so if I divide by 9, 9's a positive number, by the way, so I won't flip the sign again. X is greater than or equal to -2, and x is less than 7/9. Okay, here's that statement written back as a compound inequality. And my answer, it has to be written as either as a set or as an interval. is what I'm looking for. So the set of all x such that x is between -2 and 7/9, including -2. And since I'm including -2, I'd want to bracket by -2, parentheses by 7/9, and close circle by -2. You don't have to split a compound inequality if you don't want. I'm only doing that there just to emphasize the rule. Suppose that 1 is less than or equal to 4x minus 5 less than or equal to -2 less than 9. If I multiply both sides by -2, then 1 times -2 is -2. Then -2's cancel, and 9 times -2 is -18. Now, because I'm multiplying by a negative, I got to flip the signs. Okay, so I add 5 now. -2 plus 5 is 3. 4x minus 5 plus 5 is 4x. -13 minus 5 plus 5 is -13. Okay, and lastly, I divide by 4. 4 is a positive, so 3/4 greater than or equal to x greater than -13/4. Here would be that statement rewritten, seeing the smaller number first, which is how we'd prefer to read that. And by the way, I'm writing my answer as a compound inequality. Okay, and also writing it as a set or as an interval. Okay, here I've got a set notation written. Set of all x such that x is less than, greater than -13/4 and less than 3/4. Okay, and I'm including 3/4 in my answer. Okay, so I've got problem 78 on page 132 is a good one, I thought. Use the figure to solve each equation or inequality. So we've got 3 lines. One line is at a height of y = 200. Another one is at a height of y = 400. And another is a slanted line going through y = 600 and x = 6. Okay, so I first want to solve 4x equals, or f of x equals g of x. Now the answer to this one is where exactly does the graph of f and g meet? Okay, now keep in mind here that f and g right here meet at x = 4. Okay, so now I don't have things written out for f and g. That's okay. I don't need them. I know that I'd be solving for x. Okay, that's why every one of these answers are in terms of x. G of x equals h of x. Okay, where does g of x and h of x meet? X = 2. Okay. Part C, f of x less than g of x less than h of x. So where is f in between h and f? Well, if x is between 2 and 4, you're going to be between h and f. G of x greater than h of x. Well, let's see here. So where is g of x larger than h of x? And they're talking about the y values. It looks like anything that is between 0 and 2 including 0. So if x is 0, 0 600 is bigger than 0 400. But this graph does not include values for which that is outside the range of 0 to 6. In other words, there's no arrows on that. Okay? So problem 100 is another one. Cost of education. The cost of a K through 12 education per student was $2,200 in 1978 and increased to $10,300 in 2008. Find a formula for a linear function c that models this cost in dollars, where x is the years after 1978. Okay, so the years after 1978, I basically use the 2 points that are given to me here, 0, 2,200, and 30, 10,300. The change in the y values divided by the change in the x values would be what? Well, 10,300 minus 2,200 divided by 30 is 8,100 divided by 30, that's 270. It's easiest to use this here with 0, 2,200, since 2,200 is the y-intercept. So my answer would be 270x plus 2,200. Okay, and B, let's take a look at B. Estimate when the cost was more than $7,600. Okay, well, I would set the cost function to be bigger than $7,600. And the cost function, c of x, is 270x plus 2,200 greater than 7,600. Okay, if I solve for x, 270x greater than 5,400 divided by 270, x is greater than 20. So let's see here. 20 years ago, 20 years since 1978 is 1998. And now this is a strictly greater than, not a greater than or equal to. So I'd say after 1998 is my answer. Okay. The homework in this section is on page 130. Here are the problems that I'd like you to look over.